Have you ever thought about what it would take to tame one of America's most powerful rivers? I mean, really bring it to heel. Well, that was the incredible challenge behind the Hoover Dam. It's an absolute engineering marvel that completely transformed the desert, bringing power and water to millions of people.
All right, so here's how we're going to break it all down. First up, we'll look at the Colorado River back when it was wild and why this dam was even necessary. Then, we'll get into the mind-blowing engineering that actually built it. After that, we'll talk about the power it created and the price the environment paid. And finally, we'll see how this 20th century giant is holding up in the 21st century.
Okay, let's dive in. To really get this, you have to picture the Great Depression. The American Southwest is this harsh, super arid landscape, and right through the middle of it runs the Colorado River, a force of nature that could give life-giving water one day and then just catastrophic destruction the next. And this quote from FDR really hits the nail on the head. He called it a 20th century marvel. See, building this dam wasn't just about concrete and steel. It was a symbol of American resolve. It was this huge statement that even in the depths of the Great Depression, the nation could pull off the impossible.
So this really breaks down the why. On one side, you've got the problem, the wild Colorado. It's causing these devastating floods. The water flow is all over the place, so you can't really farm with it. And it's dumping so much silt that it's clogging up canals. But on the other side, the vision, a single massive solution for everything. Control the floods, create reliable water for farms, generate a ton of clean energy, and basically light the fuse for the growth of cities like Los Angeles and Las Vegas.
Okay, so the vision was there, but the next question was a big one. How in the world do you actually build something strong enough to stop the Colorado River? This is where the story shifts from why to how, and it becomes one of the greatest engineering feats in human history.
The answer they came up with was just brilliant in its simplicity, the arch gravity dam. Now this concept has two parts. The gravity part? That's easy. It's just a huge, ridiculously heavy wall. But the arch part, oh, that's where the real genius is.
Think about it like this. If you just built a flat wall, all that water pressure would push on the middle, try to bend it, and create tension that would crack the concrete. But by curving the dam into an arch, that exact same force from the water now squeezes the whole structure together. That's called compression, and it turns out concrete is incredibly strong when you squeeze it. The arch design cleverly funnels all that pressure sideways, pushing it right into the solid rock walls of the canyon. The dam literally uses the river's own power to wedge itself even tighter into the mountains. How cool is that?
But there was a huge problem. You can't just pour a block of concrete this massive. The chemical reaction that makes concrete hard, it also creates an insane amount of heat. The engineers did the math, and what they found was shocking. If they built the dam in one single pour, it would take, get this, 125 years to cool down. The resulting stress would have cracked the thing to pieces, a total failure.
So they had to get creative, and their solution was truly ingenious. Instead of one giant pour, they built the dam as a series of enormous interlocking blocks. And inside every single block, they ran a network of steel pipes. Then, they pumped cold river water through those pipes, basically creating a giant refrigerator to pull the heat out as the concrete cured. Once a block was cool, they just filled the pipes with grout. It worked so well that, to this day, there are no heat-related cracks in the Hoover Dam. Just incredible.
Of course, we can't forget this whole thing was built by human hands. We're talking 21,000 men working in some of the most dangerous conditions imaginable. You had these legendary high-scalers who would dangle on ropes hundreds of feet up, clearing loose rock with dynamite. It was so dangerous that the workers themselves invented the first hard hat by dipping their cloth hats in tar to make them rigid. And sadly, over 100 people lost their lives building it, a really stark reminder of the human cost of this marvel.
So the dam gets finished, 2 years ahead of schedule, I might add, and right away the transformation of the Southwest kicks into high gear. It brought these enormous benefits, for sure. But as we're about to see, it all came at a pretty significant price.
I mean, the numbers here are just mind-boggling. On average, the Hoover Dam pumps out about 4.5 billion kilowatt-hours of electricity every single year. That is enough to power the lives of 8 million people across Nevada, Arizona, and California. It literally lit up the desert and fueled the explosion of the modern Southwest.
But here's the thing. You can't just stop a major river in its tracks and not expect there to be consequences, right? This incredible feat of engineering had a deep and permanent impact on the entire Colorado River ecosystem.
The dam basically created a whole new river. Think about the before. The Colorado was a warm, muddy river with natural seasonal floods that deposited all this rich silt.
And the after? The water being released from the bottom of the reservoir is now way colder, the flow is totally artificial, and with all that silt trapped behind the dam, you now have this clear water that's actually stripping away the riverbanks downstream.
And the ecological fallout was drastic. That clear, fast water literally dug out the riverbed, making it 4 meters deeper. The cold water was a massive shock to the native wildlife, and several warm-water fish species went extinct. Today, species like the bonny-tailed chub are endangered. Their entire world was just changed forever by the dam.
And that brings us to right now. Because the Hoover Dam, this monument built to conquer nature, is now facing a threat it was never designed for: a hotter, drier climate and a Colorado River that's shrinking.
It's such a powerful contrast, isn't it? The very structure that was celebrated as humanity's triumph over the elements is now seen as being incredibly vulnerable to them. It's kind of the perfect symbol for how our whole relationship with the environment has shifted over the last century.
And this chart, wow, it tells the story in some pretty stark numbers. At its peak, the dam could crank out over 2,000 megawatts of power. Today, its output is roughly half of what it was back in the year 2000. And that at-risk bar shows the potential for a really catastrophic drop if those water levels keep falling. So you might be asking, why is low water such a big deal for the turbines? Well, it's because of this thing called cavitation. As the lake level drops, the pressure of the water going through the turbines also drops. This causes these tiny little vapor bubbles to form. But when those bubbles collapse, they create these powerful shock waves. They're like millions of microscopic jackhammers that are literally gouging and destroying the metal turbine blades.
And the scary part is, we're getting dangerously close to a tipping point. Lake Mead's water level is nearing a critical low. If it drops just another 20 feet, which is a very real possibility, they'll have to shut down 12 of the older turbines just to stop them from being destroyed. And that would slash the dam's power output even more dramatically.
So we end with this monumental challenge. The Hoover Dam was built to control a river, but now it's up against a much bigger force, a changing climate. It managed to tame the river of the past, but the big question now is, can this icon of engineering adapt to the climate of the future?